Hello, my friends. We are going to do a lesson today, which looks kind of like we've done for a while. We're going to find some zeros. I'll remind you that zeros are also known as roots. And you're going to need your calculator today. So have that within reach because the technology that I want to show you is from an app that I put on there. And I want to show you how to use it. It's pretty awesome. But before we do that, let's just do a quick little find the root warm up, I guess. We are wanting to find roots. I'll remind you that's when your output is 0. So you're going to set that equal to 0. And then determine what x value will create those zeros. So this is a factored form. Factored form is nice to work with when it comes to finding roots because we get to just let each factor equal 0. This one's going to be x will equal, let's see, may add 5. I'm doing this in my head. You've done this before. So 5 halves, yeah. Hopefully you got 5 halves. And the other one is x is equal to -6. And we remember that that repeat factor from the square we see would mean that this has multiplicity 2 as far as the root goes. So yeah, you know how to do that. It's nice when it's in factored form. You'll notice though that in example B here, we have a polynomial that's in standard form. So if we want to find the roots, we still want to go 0 equals 4x squared minus 8x, bring that down. And then we've got some options with this one. Since it is squared, we can do the, what's that thing called? X equals -b plus or minus, you know the one, the quadratic formula. But we also could factor. This is one that I think factoring makes the most sense. You think about these two terms and what's a greatest common factor. You could pull out f4 from each of them. So let's do that. You also notice there's x's in each one, so we can take out at least one x from both of them. And then we write down what's left as our factors. Taking the 4x out leaves one more x as a leftover factor. And on the next term, if we take out a 4, divide out a 4 from 8, is going to give you 2. And you've already pulled out the x, so this would be -2. And then we would always just in our head distribute that and see if it doesn't give us this back, which it does. So we're good to proceed. And now that we have it factored, it's just like this one. We are going to set the factors equal to 0 and find those roots. So 4x equals 0, and that means x is 0. That'll be one of them. The other root would be where x is equal to 2. So we get 2 roots just as the degree says we should. All right, so we have a few options. We can factor. We can use fun songs that give us the quadratic formula if it's a quadratic polynomial. But now we hit part C, and the first thing I notice is it's cubic. It does not have the quadratic form, and so I can't use that. That goes out the window, the x equals -b plus or minus the square root of b squared minus 4ac all over 2a. It doesn't work here. It doesn't work here. So you might decide if you want to try to factor that, and I'll just tell you right now, it doesn't work here either. You can't factor it. So if you can't use a formula and you can't factor it, then what? Well, the answer is the technology I gave you. I gave you an app. It's called Polynomial Root Finder, and it will find the roots for us. And sometimes that's what we need is the technology. So let's walk through that. Your apps button is where you want to start. That's the purple button right here. Hit that. Well, okay, you want to start by turning it on. Hello. All right, once it's on, then hit the apps button, and you'll find a list of applications. And my list is pretty long. Your list might be very short. It just depends on what's in there already. But you're looking for an app that's called Polynomial Root Finder and Simultaneous Equation Solver. And what they call that for short is Polysmolt. Polynomial for poly, and smolt is the simultaneous equation solver. So if you start arrowing down until you see that, this is a long list. Okay, if your list is long like mine, let me do this again. Let me quit out of this and try again. If your list is long like mine, then just know that it's in alphabetical order. So you see the algebras and the C's, it's in alphabetical order. So if you do alpha and then P, because it's called Polynomial Root Finder, alpha P will jump you at least to the P section. There's my P applications. And this one right here is the one you're looking for, Polysmolt 2. It's version 2 for Polynomial and Simultaneous Equation Solver. So please arrow down and open up that application by hitting enter. You get to this title screen, and then you want to just press any key and it'll take you into the app. And here's the main menu. And we're going to use the first choice, the polynomial root finder. So select number 1. And we get to set some information in here. So the first thing they ask us for is what's the order of the polynomial. Now they're using the word order. We've been calling this the degree of the polynomial. So that's the same thing. Order and degree are the same. And this is a degree 3 polynomial. So make sure the 3 is highlighted. And then you get options here. Do you want real answers only? Do you want, these would be imaginary answers. You see the little I there? This is another form called for the polar form of answers, and that's a different thing. We are going to try to stay in the real world when we can. So this is going to be real answers I'm going to request. Do you want your answers as decimals or fractions? That's up to you. Sometimes you don't have a choice. If it doesn't factor, it probably doesn't give you a decimal, or it probably won't give you a fraction, excuse me. All this stuff, I would just leave normal, leave this at float. Doesn't matter radian and degree, and then let's hit next. So if you hit next, this is a tab, and you're actually going to access that next by hitting the graph button. So it's kind of corresponding to the button here. For example, if you want back to the main menu, then you hit this y equals button to do it. So we're going to go to the next question. And they're giving us a polynomial form. And what they're telling us is that the A3 needs to be the coefficient of the cubed term. All right, and all the way down. So A3 is the coefficient of the cubed term. You look at your polynomial and you see that that's a 1x cubed. So we want to put a 1 in here. Then arrow down, and now it's asking for A2. That's going to be the coefficient of your squared term. So in our polynomial, that's -7. And so on. The linear term, which the first degree is just this 4x. So we want to put in the 4 for that. And the final A0, that's the constant term. So this will be 30. Is it negative? No, positive 30. Okay, now we want to solve. So we're going to hit the solve button that corresponds again to this graph right here, the solve tab. And the calculator does its thing and generates for us the roots of the polynomial. And notice there are 3 roots, just as the degree 3 requires us to have at least, or no more than 3 roots. Okay, so you just want to jot those down. Now, there is a little bit of work you have to show me. You have to show me the equation you solved, because you started with a function. And the equation you actually solved was that this was equal to 0 as output. So 0 equals, then write all the rest down. I need to see this as your work. All right, and then you can just give me the solutions you got. Now I like how it does x1 and x2 and x3. So the first one of my intercepts, one of my roots is 5. Another one is 3.64. I'm going to round that to 6. And the last one is -1.64. And again, I'm going to round that to 6. So we have these 3 roots. And those are the solutions, or the zeros. These are the zeros for my function. But the work is right here. Okay, so I want to see this. This is the show your work line. And then you can give me the solutions that the Polysolve gave you. So that Polysolve is really, really handy, especially when you can't factor, but this would be one that would be impossible to factor. Okay, now what I'd like to do is pull some examples straight out of the worksheet that you're going to be doing in your homework tonight. So if you've got that handy and you want to open up to that worksheet, I'll also just copy the problems here and you can do that with me. I want to just run you through some examples of what you're going to be doing. So the first one, problem number 1, is the one I want to start with. It's a good place to start. We are looking at a polynomial in factored form. We've got x minus 3 cubed, and then 2x plus 1 squared, and finally x plus 4 to the 5th power. And it's an inequality, the question being when is that going to generate a value that's greater than 0? So we have done a little bit with this before. This is a good just little recap. We're going to start by figuring out where this is equal to 0, and that means from factored form we're looking for roots. So each factor is going to generate roots here. X would be 3, and it's got triple multiplicity. Let me make a note of that. Moving to the next factor, the x-intercept, or the x root here, is going to be -1/2 with double multiplicity, as we count that as 2. And finally, the x is equal to -4, and we're going to mark that this has triple multiplicity, times 5. Next step is to put these on a number line so we can organize a little sign chart. And the leftmost point would be -4. After that's -1/2. And finally, we would have our 3. And we're going to note that these are generating 0 as outputs if we were plugging these into the function. Finally, we want to decide whether these individual intervals are positive or negative. And that's back to end behavior to do that. So remember these end behavior models that we've been building. Let's just do that real quick for this one. Pulling the lead terms from each factor. X cubed, 2x, all of that 2x squared, and then x to the 5th. So x cubed multiplied by 2x squared, make sure you quantify that, and then x to the 5th. Okay, because this 2x squared, it's all of it is being squared. It's actually 4x squared if you drop the parentheses. Let's bring these others down. Okay, multiplying that all together is giving me 4x. I'm going to add these exponents. 3, 2, and 5 makes 10. 4x to the 10th. So the ends of this polynomial would graph out both up. It starts positive, and in the end, it's positive again. So let's record those signs in our chart. Starts positive, and all the way at the end, it's positive again. All right, now, do these signs change or not? Well, I didn't bring down these multiplicities, so let me go ahead and do that. The -4 was a fipple, here I go again. 5-time multiplicity. -1/2 had double multiplicity, and this was triple multiplicity. So think about whether the sign would change or not. If it's got the 5, that's going to indicate we're moving or passing from positive, crossing through into negative. So there's a change there. This is the double multiplicity. We're negative, and we're going to touch, kiss, go right back down into negative. So there's no sign change right there. There should be a sign change here as we move from negative and cross through into positive. So this is what our signs look like. Now let's go back to the original question and just see which part we're really interested in. So here's the original indicator, was that we wanted the positive greater than 0 values. So those are these intervals here. And it looks like we're not including 0 as a possibility. So these are going to be parentheses, soft bracketed on the ends here. So our answer needs to be our intervals from -∞ to -4, non-inclusive. Secondly, from 3 on up, so 3 to +∞, we're non-inclusive on that 3 as well. These are our solutions. All right, so with number 1 under our belt, let's go, I would like to go next to number 11. And as we look at number 11, we have another inequality. Let's take a minute to jot it down. We're looking at x cubed minus 3x plus 7, and we would like to know when this is greater than 0. So another positive one. Okay, so check this out. It is not factored. We have standard form. Figuring out where this equals 0 to get our roots is going to be a challenge because it's not quadratic, so we can't use a formula. But Polysolve to the rescue. We can use our Polysolve. All right, so I'd like you to tell me what equation you're going to solve, which is just to figure out the zeros. You're going to just let me know. You're going to solve for where this equals 0. And then let's open up that app. Now, what is this? I don't know what that is. Let me clear that out. Okay, so here we are. I don't know what's going on. Get back to the main menu. That's where you want to be. Back to the main menu. And we'll do the poly root finder again. Okay, so again, the order is the degree. So order here is 3, just as the degree is. And we're ready on the rest of this. Let's go to next. So hit graph button to go to next, and let's enter our coefficients. So what's our cubed term? The coefficient of it anyway is 1. So I'm actually good to go there. Let me arrow down and ask, what's the squared terms coefficient, that A2? What's the squared terms coefficient? And you see there is no squared term. So you might guess, what do I put in if there is no squared term? And the answer to that is 0. You may have guessed that. Then we have the linear term. So this is our -3 for A1. and our constant term is 7. So if you, oh, I didn't get my -3. Let me go back. Okay, so if you're satisfied that you have the coefficients in right, just hit the graph button again to solve. And we only have one root here. So we only have one solution to this equation that we can call real. I was expecting 3 solutions, but I only got 1. So what happened to the other ones, I wonder? Well, I know it's not a huge deal because the number of roots I get is always no more than the degree. So this satisfies that. But I do want to show you something pretty awesome. I want you to go back to the main menu. Let's go back there and do Polyroot Finder again. I want you to, from this menu, I'd like you to change this designation of real over to this one, where we're going to be accepting the imaginary answers. So let's just arrow over and hit enter to select that. Now this time it's going to tell us all the roots, including the imaginary ones that we normally don't want. So hit next. These coefficients should still be the same, so go ahead and hit solve. And there we go, we've got 3 roots. So why didn't it give us these 2 roots before? Well, the answer to that is because these 2 roots are imaginary. And how do I know these are imaginary? Well, if you'll take a look all the way to the right end, you'll see 3 little dots that indicate there's more after this. The window is filled and there's more to come. So arrow down and over until you can see what's after those. I'm arrowing over on that middle line and I can see there's more. It's got a plus, there's a 1.18, and if I keep going all the way to the end, there it is, hiding, that little I. So that tells me that this root was one of the imaginary roots, as well as the second, or the third one, that little dot, dot, dot. That's how I know those were imaginary. So you be watching for those. If you see those, you don't want them as answers, but that does account for the other 2 roots that we were missing out of our list of what we expected to get 3. Okay, so now that we've seen that, let's go back to the problem and let's just finish this off. We've got 1 root, which means on our number line, we put 1 root down, this one. And we make a note that that's equal to 0 right there. Are we positive or negative on these ends? So let's test it out. So our degree and lead term tells me that the ends of this should look like, let's see, that's an odd. They're kitty corner and they start down and end up. So that means on the left end I've got negative values and on the right end I've got positive values. And there just happens to be only those 2 ends. We've got this one's going to be negative and this one's going to be positive. Nothing else to it. Okay, it's time to write our answer. Again, we want to highlight where we find positive or greater than 0. So anything greater than 0 is going to be positive. That'll be here. And we will not include the 0 itself, so we'll soft bracket that. Our final answer is negative 2.46 or 2.426 up to positive infinity, non-inclusive. And that takes care of problem 11. Okay, I want to do 2 more just so you know kind of where I'm going with this. The next one I'd like to do with you is number 17. Take a minute to locate 17 and write that one down. 17 is a different question. There's actually a typo in it, so if you guys would fix this. It was intended to say f of x is equal to the square root of, what is that, 4x to the 6th minus 4x to the 5th minus 48x to the 4th. But the f of x equals got dropped by accident, and so it really needs to be there because the question that it wants us to do is to find the domain, and if it's not a function, we can't find the domain. Now, I will remind you that we have done these find domain questions before, so do you recall that if you have an even root, any even kind of root right here, if this is even, which it's a square root, so that is even, then the restriction is that we can't take even roots of negative numbers. In other words, this entire radicand part right here, that part must be positive or 0. You can square root positives, you can square root zeros. You can't square root negatives, so we need this restriction. So to find the domain, we are going to pull that out of the radical, and we are going to basically solve this inequality. Where does this radicand take on positive or zero values? Well, that means greater than or equal to 0. And this, I notice in the directions, this is a no calculator question. So that Polysolve, although I'm kind of tempted to use it, I'm not allowed to, which means there must be a way to solve this. And since it's not quadratic, I'm going to think about factoring it. So let's work on this factorization. Looking first for any GCF that you can find. Now the 4 and the 4 and the 48 make me think that there's a common factor there, and 4 is my common factor. 4 does divide into all of those values. Also these x's, how many total could I get out of each one of them? I'm going to take the x to the 4th out because I can. And then what do we have left over? Pulling out the 4x to the 4th, there's still a remainder factor here of just x squared. Let's check that. 4x to the 4th times x squared is 4x to the 6th. Next term, we pulled out the 4, we pulled out x to the 4th. We have a remainder factor of negative x. And on our last term, the 48 had a 4 divided out of it, which left the other factor to be negative 12. And the x to the 4th takes care of all the x's. So this is the constant, negative 12. Okay, I'm bringing down the rest. Now, let's work on this quadratic part. Can we factor that? And yes, I think we'll be able to. Now, this one is that X box pattern where we want to get 1 times negative 12. That's the value we need to be making a product out of. And the middle term, this negative 1 it would be, that's the number we need to get a sum out of. So thinking about what numbers can multiply to negative 12 and add to negative 1. Some of you are probably shouting right now that it is 3 and 4, and you're probably telling me that the negative belongs on the 4 so that I can add to get negative 1. And I believe you would be right about that. So the factors. And I can go straight to the factors because, again, that's a 1 as I'm a lead coefficient. That means these are just normal x's. And then these numbers come in to finish off the factors, a positive 3 and a negative 4. And don't lose this guy. Bring him down as part of the factorization. All right, let's ready, rock and roll. Let's figure out what our roots are, and I am going to put them on my number line even as we speak. Okay, the first factor will create a 0 if x equals 0. And multiplicity on that x is fourfold, 4 times multiplicity. So 0 is one of my roots, multiplicity 4. The next factor is going to generate a root of x equals negative 3. I'm going to put that back here. Just single multiplicity there. And this is another single guy, x equals 4. So he's going to come right here. But that fourfold multiplicity, we're going to make sure we don't change sign there. Okay, how about the ends? Using 4x to the 6th as my lead term, what does that tell me about the ends? That's even, so they're going to be together, and positive means they're together up. Okay, so the signs of this are going to start, the left end is positive, and by the time we're done switching and switching, the right end better be positive at the end. So this is positive to start. We switch at this 0. Let me make a note that this is 0. We make a switch from positive and go into negative. We make a fourpole switch, which is even, so that means there's actually no switch that happens. This is still negative. And at this 0, we transition from the negatives into the positives. And check your end behavior, your positive on the right, just as we predicted. Okay, it is time to write our answers. So we go back to the beginning and see what our goal was. It's here as well. We must get positives or 0 out of that radicand. In the number line, that means anything that's positive I want, and anything that's 0 I want. So I'm here and here, and here. Just that single point. So we have an entire interval up to and including the 0 we created with the -3. And we have a second interval here, and we want the 0. Because remember, if the polynomial generates 0, we are allowing it to equal 0, we want to keep it as an answer. So the domain of this function is everything we just shaded in there. -infinity to -3 inclusive with the hard bracket. The other interval from 4 to infinity, and just the single value where x equals 0. That's our full domain. All right, I'm really thinking that I want to do one with Polysolve again. So let's make our last example question number 31, where we are allowed to use a calculator to help us. Okay, so we'll finish it off with this, 31. And we are looking at, again, this should say f of x. Please add that. F of x equals the 6th root of 1 minus 7x to the 5th minus 70x to the 4th plus 4x. Find the domain. All right, this starts out very, very similar to the last question. Is our root even? Yes, so that means that we aren't allowed to have anything but positive or 0 under that radical. So we need to solve this. When does this generate positives or 0? Let me write it as greater than or equal to 0. This is what we have to solve. Okay, now we're not going to factor, and we're not going to do anything but Polysolve to find our root. So here we get the calculator. Let's go back to the main menu. And number 1. And what changes do we need to make? And be very careful, because we are not in the standard form order. We're not in descending order. So be careful. What is the degree of this polynomial? And it's going to be, our lead term is actually the second term right here. So degree is 5. Arrow over, hit enter for 5. Now I want you to notice you're no longer allowed to choose real as your option. The only option you have when you get up into those higher degrees for this app is the imaginary inclusive one. So be careful, make sure you watch for that ... and throw out any of those imaginary answers you get. Moving on, let's go to next, and let's enter our coefficient. So A5 should be the coefficient of the x to the 5th power term, which is -7. A4 is -70. A3, do we have a cubed term? No, we don't. So that's going to be 0. Just as A2 is, since there's no squared term, we're going to have 0. A1 is our 4x from x to the 1st degree. And A0 is all the way at the beginning, this 1, this constant. Okay, when you got those entered, then hit solve. Let the calculator do its thing. And I expect 5 answers because I'm degree 5. But I'm careful, are any of these imaginary answers? You want to be looking at the ends. There's one there, there's one there, the ... That means if I were to arrow over, I'm going to see those imaginary I values. So don't use those as answers. We only want the real numbers. So we've got 3 real roots here, which I'm going to put on a number line. Starting with the leftmost one, which is going to be this -10. I'm going to call that -10 because of all those zeros that come after it. So -10, and then the 0.440 or 0.441 if you want to round it, that's positive. And then we have another -1 that's not that big. It's just -0.214. And don't worry about the scale, just get them in the right order. Okay, now what do the ends look like? Degree here was 5, lead term was -7. So we're kitty corner ends. Negative means we flip-flopped it. So it's up first, then down. So on the right end, sorry, this is the left. On the left end, we're going to have a positive to be up. And each of these, there was no multiplicity to worry about. So each of these is going to be a switching place. We're going to move from positive into negative after we hit a 0. we'll hit a 0 and then we'll move from negative into positive and hit this 0, and then our graph would move into the negative, which matches our right end here. Okay, our answer needs to be anything that gave us positive or 0. So that's here, inclusive, and here, inclusive. We're going to hard bracket all the zeros and write our answer as domain is negative infinity to negative 10. And then that last section, oh, I did that wrong. That's inclusive. Hard bracket that. And hard bracket this one. Negative 0.214 up to 0.441. And we're hard bracketing that. This is our domain. Okay, it's your turn to practice. Remember, you can text me, email me, and I can help you if you get stuck, but please pay attention on this assignment to directions. If you're not supposed to be using a calculator, make sure you're not using a calculator. If you are allowed to use a calculator, go crazy with the Polysolve. And one last reminder, this is a really common error. I get a lot of questions about this. I don't know where on your worksheet it is, but there's a problem in there that's got something like a cube root or a 15th root or something, and then blah, blah, blah. And it's tough. It's really hard in there. But the key is right here. If that's odd, then your domain doesn't matter. In other words, the domain is anything is okay, negative to positive infinity, because you can cube root or take any odd root of anything you want. There's no restriction. So don't let those problems throw you. Those are probably the easiest ones. Be on the lookout for odd roots. Answer is always negative to positive infinity on the domain. Good luck. I'll see you soon.